set up a pool. These are things that you have to explicitly do and make sure that you have a way to distribute requests to different database connections. And same for any other resources that are constrained like that, like SQS or Elasticsearch or anything else. And this is kind of one of the most important pieces, because like I said, Node is going to crash, and you need some kind of thing to restart it. Now, there are a ton of different supervisor tools. I have tended to just use Upstart, which is etc init, because it's already installed, and it does most of what I need it to do. There's an old classic package called Daemon Tools that does it, and there's a whole bunch of other things that I don't even know about that do it. And I don't really care, just as long as when Node crashes, something starts it back up immediately. And if it crashes again, something starts back up again. That's really what you want. And it's going to be really important because we're going to get some later bits that are kind of relying on that. So this is a really bizarre situation we have in Node Core right now. There's this thing called domains, which is a really stupid name because we have domain names, which this has nothing to do with, and we have Windows domains, which this has nothing to do with. But this is this other thing called domains, which is this sort of like erroring domains. And if you look it up in the documentation, it says deprecated 0, do not use. And then if you look into it and you say, well, why is that? What are we supposed to use instead? They literally have nothing. There's nothing else that you're supposed to use other than just to know that this is deprecated. But this domain thing will absolutely save your life. That same diagram I showed you where one connection is blowing up and it's taking down the entire node process, if you have your domain set up correctly, you can actually catch it at that one connections level. You'll 500 on that one request, but the rest of your connections will be able to finish and they'll be able to terminate normally. The node docs also tell you that if one of these domain things happen and you catch an error, and I'll show you some code in a minute, but if one of these domain errors happen, you should try and shut down. Don't sit there and keep limping along. And my policy is if the node guys say to do it, I'm going to do it that way. So that's what I do. And also if you're using something like Express or any of the other middleware packages, they probably are doing this for you already. So this is all you have to do to use domains. I mean, the main thing to note there is just we're doing a domain create, and then we're associating the request and response for the HTTP server with that domain create, and then we set an error handler, and that's it. I didn't put all of the error handler stuff in there because the font would get too small, but that's basically all you want to do is return a 500. That's where it says write head 500. That's returning a 500 error, and then an error message, and then that one connection can terminate, and then I would actually shut down the server and then let the restarter start it back up. So this is more obvious advice. Logging and monitoring is great, and you should centralize it, and that's good. The only additional piece I would say is whenever your server starts up, say something like magical in the log so that you can find it. So that if you have a problem where your server keeps crashing every hour or something like that, you can scroll down, find a thing where it says start server, and then back up and see what the error that popped out before that was. So in terms of the types of servers that you want to pick, I like to do smaller RAM, single CPU if I can. Unfortunately in AWS that is not that easy because most of the servers end up being two CPU. If you really have to, you can use multiple CPUs, but if you can avoid it, if there's any way for you to avoid it, you can simplify your infrastructure substantially. Because if you have to use multi-CPU, you end up having to use this package called cluster, and then you have to build in this sort of process management where you're dealing with what happens if one of the children dies, and then you go and restart it, and at that point you're building kind of, you're building your own copy of Daemon Tools or init or whatever. It's better if you just have one process, have it do its one thing. And like I said, Amazon doesn't have really good single CPU boxes for this type of stuff. And that leads into this, which is, okay, so we know how one box is going to look. I would argue that you should never put Node in production on one server. It should always be more than one. I like 3, depends on how many availability zones or what your infrastructure is. But I would never put anything in production on just one server. Because again, it's going to be crashing. There's going to be stuff that's going to, I mean, this is only if you're hitting it, you know, hard enough. But that server will fall over at some point, and you're going to have to restart it, or possibly restart the entire server. You want to have a collection of redundant servers to be able to handle that. So certainly you're going to need stuff like health checks, stuff like that. I like Amazon Elastic Load Balancing and Amazon Autoscalers, I think, are really spectacular. They're a great way to handle these types of things. And that is it. I am at UberBrady on Twitter. I am Brady on the San Diego JS Slack. I am uberbrady.com if you like reading blog posts. And then there's my email address if you're one of those three. But that's it. Any questions?
Have you used anything like PM2 to manage all your instances?
No. I mean, our setup is, like I said, we use autoscalers pretty heavily, and we have a lot of homegrown infrastructure that will go. And basically, I can bring up a server inside of about a minute, 2 minutes, where it'll come up from like bare metal and then be actually running my application inside of 2 minutes. And that's all like custom built and designed to be like super fast. Again, under that assumption that stuff's going to be crashing all the time. So it's going to be crashing all the time, and you will spin up a new one. And then the other nice thing that the autoscalers do is that you can set, if CPU is where you're running out, you can set a CPU limit where if aggregate CPU usage is greater than 80% for like 5 minutes, spin me up a new server. And so if you ask me how many servers I have now, I can't tell you because I don't know. It's somewhere between this number and this number. Depends on what load is looking like. Right? Yeah, sure.
How do you tune your expectations in terms of how often, like with 100 million transactions a month, how often are your servers starting?
Yeah, we usually, what we'll end up doing most of the time is when we first put something out, we'll have missed one common error that happens, sure, not when you're doing it 100 times or 1,000 times or 10,000 or 100,000 times. That one starts to come up and you're like, okay, let's catch that one specifically. And then if we've got that domain system that I mentioned in there, we can at least sort of gracefully terminate the server and have it not completely fall over. But I mean, when I've had really sick services where the server is bouncing every like 10 or 15 minutes, and that absolutely sucked. But again, with enough servers and it's spread over enough time, we managed to stay up. But that's one of those things where that's a real problem. And I've been trying to work on figuring out a way to set up a metric for restarts per unit of time, where like I can say, hey, if you're restarting twice a day, I don't really care. If this thing is starting to restart, like 10 times a day or 20 times a day, then that's a real problem. We need to stop, figure out what that error that keeps triggering is, catch that one, and then see clean it. Anything else?
So Brady did the long format talk, and the rest of the talks tonight are going to be lightning talks. What that means is it's going to be a 5-minute talk, and what we're going to do is at the 4-minute mark. Who's going to do the timing? Yeah, so Todd's going to come up and do the timing, and I'll just walk you through your participation in the timing. So you guys will help out the speaker by when he gets to the 4-minute mark. It's up here. He will be holding up one hand. That will indicate to you that we're 4 minutes in, so you should then give a little golf clap, or finger clap, and then keep that going for them as we go to the 5-minute mark. And at the 5-minute mark, we'll do 2 hands up. That's it. Music plays off the stage, and then while you're answering questions, the next person can come up really quick, plug in, and be ready to go as soon as the questions are over. So that'll help us kind of get through the questions quickly so we can get to the drinking games. Right. So. Next up is Tyler Henderson.
Hi, my name is Tyler Henderson. I am interning at Rolling Down the Street, and I'm going to give you a very brief introduction to Google Maps API. What is it, and how do I use it? Surprisingly enough, Google Maps API allows you to embed Google Maps into web pages. It's simple to use, and it allows for extensive customization. There are 3 ways you can implement it. With the JavaScript API, static maps API, which is a long WE URL, and the embedded API, in which you use here is how to use the JavaScript API. You load the API like so. Add a div for your map, and give it some dimensions, and there's your JavaScript. So there you're going to be creating a function that's being called when the API is loaded, and the callback up there. And inside the function, you're creating a map, and assigning to your map div, and giving it the basic options of center and zoom. That's the very least that you need to create a map like this. So customization. You can add a marker, give it a position with a lat long, and assign it to your map variable. You can add as many of these as you want. And here's your info window. You can add an info window and assign it to a marker that opens when it clicks. You can add marker animations and custom icons. You can draw all over your maps and use custom image overlays. There's also heat mapping, street view side by side, 45-degree imagery, style maps, and much, much more. And well, that about does it. I hope I've cleared the 4-minute mark. I hope I've inspired somebody to use Google Maps API in the next project, and thank you.
Have you dealt with the embed leaks where you go and the link it gives you, if you pull the link out of the URL bar, it won't actually embed that? There's okay. That was something I ran into recently that drove me crazy. There's you have to go to the embed and get the way it formats the URL lets you embed it, otherwise it throws a CORS error.
Yeah, I implemented JavaScript maps recently in a project, and actually the async defer for the JavaScript API was giving me a lot of headaches. And also, if you're using Rails, disable turbo links. It'll mess you up. Anything else?
Have you dealt with the clustering API in Google Maps?
No. That's it.
So up next we have Max UE.
Hi everyone, how's it going? We're doing it. Hi, I'm Max. I recently moved down here about 2 weeks ago from San Francisco. So in light of the last talk, I just wanted to show you an implementation of the Google Maps using Meteor.js, which is a full stack JavaScript framework. So when I was up in San Francisco, I made an application that utilized the Google Maps API. This is it. These are all public bike parking locations in San Francisco. So as was mentioned earlier, I utilized the marker aspect to create all these different markers, and then I rendered this map. So I would like to just show you a little bit of my code and talk a little bit about Meteor.js. I don't know how many of you are familiar with Meteor.js, but we found it really effective in creating an app that was really reactive and really effective on a mobile browser. So basically, as you can see here, I kind of wanted to just show you the basic file structure in Meteor. It's set up nicely. There's these folders, the client folder and the lib folder, and there's usually a server folder as well. But basically what Meteor does is it allows you to create HTML templates, and associated with each HTML template, you have your own JavaScript file. And so we found it to be really organized and really effective for creating that location-based application. So here you can see we have this HTML code. it's a template, an HTML template. All this code right here is rendering that entire page, basically, that I just showed you. So Meteor is really easy to get things up and running quick. I highly recommend checking out the documentation at Meteor's website. So basically here we have this Google Map rendering, and then this is the associated JavaScript file with that HTML page. And so as you can see here, we render this map at the center, and at a certain zoom level, we can adjust the different aspects of the map, such as the little dude that you can drag onto the street, and the zoom icons. And then what's cool about Meteor, I think, is you can list out all these different server methods that you can see here. So these methods are on the server side, and you can call them in the client folder, in files in the client folder. So that you can see here, we do this Meteor call to get all the bike data from a public API. And that's just a method, a function here, this get bike data function. So Meteor has a lot of built-in methods that are really effective in basically performing really cool things in the client. Yeah, that's about all I have. I think I'm under the lightning talk. Thank you.
So while Ryan Espinoza, you're up next, while you're plugging in, where are you at? Are you here? Maybe he's not. No, Ryan. All right, so I think that kind of wraps things up. So if you want to answer some questions while we kind of get ready to do the closing announcements, and then I guess drink and eat.
Okay.
We'll make it. So, any questions?
Sure.
So, what were you using to determine where the bike parking is?
So we were accessing the San Francisco government's public API service, and so they had a bunch of resources there. This was bike parking, for instance, and so they had this giant JSON data chunk, and for each separate entry, we were basically organizing the lat and longe coordinates, and then calling that Meteor method in the client when we're doing the Google Maps API, like for each marker in like a for loop. So the SF public data was awesome.
Cool.
Yeah.
Did you run into any limitations as far as how many pins you could place on the map in a certain area?
No, there were no limitations in that. It's a San Francisco app, and so we have a nearby button. And one of the interesting things was like figuring out if you weren't in a certain radius, how to make it just center on a default radius. And we used the distance formula.
So is Meteor.js purely client side, or is there like server side outside? How does the server side outside?
It's full stack, and so there's like, it uses MongoDB for the database, and then it has all this kind of built-in middleware, I think. And it has its, instead of node package NPMs, it uses its own separate Meteor package system. I think it's called Atmosphere, but they're all kind of different from NPM, and they're pretty reliable. Yeah.
How many people are using Meteor? I mean, how does it compare to other frameworks in terms of adoption?
I'm very new to the field, so I don't know much. I was at a boot camp up there. I think it has a strong, we found it had a really strong community online, like on Stack Overflow and stuff. But I think it's potentially has a lot of future potential. Yeah. Right.
I've seen a little bit about like since the like database ORM is the same on server client, like adding security to that and like trying to protect the server side of Meteor. Did you look into that at all? Or?
No, we didn't worry about that too much, but one thing that Meteor does is it creates a copy of the whole database on the client and a whole copy of the database on the server. And so it predictably presents stuff before it actually checks the server, and then the server database. And so it's called like the hot push UI. So it like kind of predicts what it should show up in a sense, and then it checks the server, and if it's something different, it renders something else.